Hello kids, today I will be solving a ray tracing diagram question from the ATP paper 6 of Physics 0625. This is the May-June 2020 paper. The paper variant is 6.1. This is the question number 3, in which a student investigates the position of the image in a plane mirror, right? So the first thing I would mark over here is this plane mirror, right? So it's a plane mirror that we're discussing, and over here in the section over here and part A, it says the student draws the line MR, right, which is this MR, right, this mirror line, right, which represents the mirror. He draws a normal NL to this line that passes through the center of MR, right, which is this NL, right, this N and this L. This is the horizontal line, which is drawn using this point P, right, using a D or protector, right. He labels this point NR and crosses with the letter B, right. Okay, at this point B, it is crossing or intersecting this MR, right. This MR over here is the mirror actually, right. Okay. He draws a line from B at an angle of incidence of 30, right? A line at an angle of 30 degrees to the normal below and to the left of the normal. He labels it as line A, right? Now over here at an angle of 30 degrees, right? Over here this is 30 degrees, right? So just a minute. Okay, this is now in our case is 30 degrees, right? So let's write 30 degrees, right? This is 30 degrees angle, and in the next part, okay, he places a pin P1 on line AB. This is P1 line on AB, right? This is A and B. Over here, this is P1. And he places another pin P2 on line AB. But as you can see in the diagram, the position of the second pin is actually not known, right? So we don't know where P2 is, right? So we're just going to put a little question mark over here that we need to find this P2, right? Okay. Then he places the reflecting face of the mirror vertically on the line MR, right? Now he's placed the mirror as I've highlighted, right? Here's the mirror. Okay. He views the image of P1, P2 from the direction indicated using this eye, right? Over here to this eye at this angle, it is the person is, or the student is now viewing the image of these P1 and supposedly P2 at certain place, right? Okay, more on figure, mark with a cross suitable position for P2 in the experiment, right? Now to mark a position for P2, you need to understand that whenever we are doing ray tracing diagrams, so for ray tracing, what we call as the minimum distance, right, between pins should be 5 centimeters, right? That is the minimum, right? The minimum distance. It can be more, but it needs to be at least 5. So I will take this ruler from here, and from pin 1 I will measure how much I can get till 5, right? So as you can see over here, right? So at this point I'm just going to mark this as P2, right? So over here we have now P2 in our hand, right? I'm just going to write over here this is P2, right? Okay. This is P2 right here, Okay. Now remember that this gap is actually 5 centimeters, right? This needs to be, I will draw this, that this between P1 and P2 should be 5 centimeters at least, right? It can be greater than that, but should be. And do not place a pin right next to the mirror, right? Keep a distance between the pin 2 and the mirror, right? Okay. Now continuing forward, we're done with this. Okay, this part we're done. One mark there, right? He places two pins P3, P4 at some distance from P3, and images are viewed of the P1, P2 all appear to be behind P4, right? The positions of P3 and P4 are shown in figure, right? Now what our observer is doing is that he's able to see these two images through this, right? So we're just going to put a line here, right? We're just going to draw this line, right? And through this we can trace the image of P2 and P1 as long as they're in a straight line, right? So P3 and P4 should join at the very point where these two are meeting, right? So as you can see, this is now intersecting, right? So we're done with this part as well. So draw a line that P4 continues the line until extend 7 centimeters beyond MR, right? Okay. Now first we need to measure how much this is from here to here. This is about 7.1, right? And I will further extend it by 7 centimeters, right? So 7 centimeters mean I need to go at least to 149, right? Let me just drag the image a little bit up, right? Okay, there we go. All right, now let's go with the center again, and remember it was 79.1 millimeters, so we need to go at least 149 millimeter, 149.1 millimeters to match this, right? So we will go 149.1 millimeters, right? And we're going to match the angle like this so that they overlap. There we have it, right? So now this line over here is actually what we say is this is now 7 centimeters, right? Okay, next part. Okay, we're done with this as well. We're done with this. Okay, the student keeps pin 1 in the same position but moves pin 2 so that the angle of incidence is now 40 degrees, right? So in part B, he has now moved pin 2 so that the angle is now 40 degrees, right? The pin 5 and 6 are the refracted ray marked on this. Draw a line joining P6, P5 so that extends 7 beyond through MR. Now he's done the same thing. Now we're not going to draw another position for this, but instead we're just going to trace P5 and P6 to this, right? And beyond the mirror it should go at least, let's say, to the mirror it is counting 85.2 millimeters, right? So we need to go 7 more centimeters, right? So 70 means 80 plus 70, it is going to be 152.2. so we are going to again extend this to 152.2, right? So that's the point where they're going to meet, right? So I'm just going to extend this a little bit longer so that I am going to have an intersection, because as per the diagram we see an intersection being formed over here, so it's better to extend the line from here, right? As you can measure again that this is at least 7 centimeters, right? So till 7 centimeters they are intersecting each other, but it's better to have a longer line, right? As you can see, you need to have at least 7 centimeter line to have a good intersection. Less than that and you won't have a good intersection, right? So make sure that you're doing this very accurately with the ruler, right? As you can see, these are very neat, so use a very soft hand while using pencil so that in case if you get any mistakes, you're not messing the diagram up, because the examiner will be using a ruler to measure each and every ray or the trace that you will be making, right? So you need to be very, very accurate. Yes, there can be a very little room for error, but make sure you don't have any. Make sure that these lines and these points are very clear, they're as thin as possible and they're clear. Make them permanent, or you can say make them darker once you have solved this question. Before that, just keep a softer hand so that it's easily erasable and it doesn't mess up your answer sheet until unless you have completely solved the question, right? Okay, moving on. We're done with this part. Now label with the letter Y the point where the two lines cross, right? So we're just going to label this as point Y, right? I'm just going to label this as Y. Here's our Y, this point, right? I just marked the point as well. Okay, we're done with this as well. Here's one another mark for this. So we're done with this. Okay. Okay, draw a line from P1 to MR that meets MR at right angle. Measure and record the length of A of this line, right? Okay, now what we're supposed to be doing is that we take a point, we take a line, perpendicular line from here to MR, right? And then measure the length of this, right? So in our case, A was actually equal to 52 millimeters, or I would say 5.2 centimeters, right? So that's the value of A in this case, right? Okay, another thing done. So over here the answer is 5.2 centimeters, right? Okay, now draw a line from point Y to MR that meets MR at right angle. So we're supposed to be doing the same thing with this intersection that we just attained, and we're just going to see how much it is going to have the length, right? So again, these are just measurement questions. So this is 4.9 centimeters, right, for our case, which is, let's call it B, right? Okay, I will re-verify again these two parts, right? Okay, all right, so that to ensure that everything is done very accurately, right? So I will erase my line, this line again, and try to have a better center this time around, right? So now this is now auto snapping, so I will again erase this line too. This, as I said, that you need to be very, very accurate. Why I'm erasing this, I'll explain in a moment, because I need to be very accurate in solving this question. So I'm just going to extend the line beyond like this, and take again the center of this, and now extend the line. As you can see, by improving the accuracy, my point has actually shifted a little bit, right? Okay, I'll draw that again. And this is precisely what you're going to go through while solving this question, that your lines need to be very, very accurate to have a better intersection, right? Okay, now we're right in the intersection. I'm just going to zoom in it a little bit. As you can see now, there is the point, and now as you can see, the length of the line is 51.2 millimeters, or I would say 51. So there's a huge difference in the answer that you can have just by little error in your drawing, right? So as you can see, my reading has improved, and it is actually supposed to be very close. These, why I erase this is because that this value and this value needs to be very close, because it's a reflection of this P1, right, which is viewed at point Y over here, right? So they need to be very, very close. Again, there is still some errors there, but that is how the exam works. It does give you some room for error, but not much. Previously, we had a huge difference in the value. It was 49, and the answer was 4.9 centimeters, and the answer was 5.2 centimeters for us, which is for A. So B should be very close to this. Now I'm just going to record this value because now this is very close to it. I'm just going to write 5.12 centimeters, right? And over here you can also have three significant values, right? But just by adding another 0, because the paper is always referring to three significant figures, so you need to understand that we need to have three significant values. If you don't have any, then just put a 0 at the end to match the number of significant figures to signify the accuracy of the answer, right? Okay, so this is also done now. So we're done with this. We're done with this. Remember, I'm just telling you that these two need to be very close, but you need to just record the value that you have noted. Do not try to create your own answer if your lines are you're representing something else, right? So if you've drawn this permanently and it's a permanent drawing, if you're gonna raise this and it's gonna mess up your answer sheet, do not raise that and just try not to you can say recreate your own answer. Just get the value of whatever you have recorded using the ruler, and that should do the job, because the marks are for following the instructions and not for you can say the entirety of the answer. So there's always a little error and room for error for diagrams or questions like these, right? So in our case it was a little different. Okay, the student removes all the pins. He places pin P7 on the normal at a distance 6 centimeter from in front of the mirror, right? Now we need to look for P6, which is 6 centimeters from the mirror. He views the image of P7 in the mirror. He places P8 on the normal behind the mirror, right? He adjusts the position of P so that the image of the bottom of the P7 and the top of P8 are seen above one another, right? So what he did, the student has now taken point 6. We're going to take the center. We're going to have 6 centimeters, right? So here we have it. Here's our 6 centimeter, right? This is now P7, right? I'm just going to make a little dot over here. Now this is P7, and there is another P8 which is over here, right? This is P8. Now this is P7, right? I'm just going to highlight this up. Okay, this is what we have to draw. On figure 3.1, measure the distance x along the normal between P8 and the mirror, right? So simply take your ruler and measure this value from the center of this point P8 to the mirror, right? This is 63.1 millimeter or 6.31 centimeters, right? So we're going to go with 6.31 millimeters, right? So 6.31 centimeters, sorry, right? Okay, just record the value. As I said, do not try to recreate the answer on your own. Whatever the ruler is telling you, just write it down. Okay, complete the diagram to show the appearance of P7 and P8 as described, right? Okay, let's say what you need to do is that how it is going to appear. So let's say if this is P7, right? Okay, and we are now going to have this use different colors, let's say black and blue. So I will use this, right? Okay, So simply mark this out with different color pens, that this is P8 and this P7, right? In front from back, right? They should line up like this, right? For example, this is P1 and this is P7, so they should line up together, right? This is what the experiment is all about. So another mark here, another mark here. Okay, the student expect the reading to show that the image formed in a plane mirror is the same distance behind the mirror as the object in front. Readings of A and B and X, A is equal to B and X is 6 centimeter, will show this, right? Okay, state whether your readings show that the image formed in a plane mirror is the same distance behind the mirror as the object in front of the mirror. Justify your statement, right? Now over here is just a justification statement, so you need to worry about the logic and you don't need to be very accurate with this. So now what the question is saying is that, is it possible that this P7, which is we measured, that this is actually 6 centimeter, right, from the center, right? This was 6 centimeter that we measured, right? Should also be equal to what we're going to expect over here, like this, right? So this is also supposed to be 6 centimeter, but in our case it's 6.3 instead of 6.0, right? So are they supposed to be same? Yes. They should be whether the readings show. Now you need to understand, if the readings are showing this, if the readings show that the image formed in the plane is as the same in the distance, right? With care suggest a practical reason why the result may not be accurate, right? So these are the two things now that we need to understand and justify our answer, right? So now state whether the readings show that the image formed in a plane mirror is the same as behind of the mirror. Justify the answer, right? So from reading, they are not same, right? And what is the justification? There could be some error in placing the pins, right? So that is one way of justifying this. Okay, now the student carried out the product suggests a practical reason why the results may not be accurate. The thickness of the mirror is not accounted for in the readings, right? That's the basic problem, right? Because what we are doing in this diagram, as you can see, we're representing the mirror using this straight line, right? It's just a thin line. Now we need to understand that the mirrors are actually a little thicker. I'm just going to draw a mirror, right? So what we are doing in this question is that we are not measuring this distance over here, right? So this is the thickness of mirror, right? And that is probably the difference, since this was 6.31 centimeters and this was 6 centimeters, right? So as you can see, there's a big difference in these two values and they're supposed to be the same. And why is that? Because what we measured is the distance to the front, right? And the second pin that we are measuring to this line, while we ignore this value, right? We have ignored this thickness. So that is the very reason why these two are not matching. And as you can see, I just said that there could be some error in placing the pins, and now you can add further to it, because the thickness of the mirror itself is not accounted for, right? And that's the same thing you just answered in the next part, right? So that's how you can simply manage to answer this question easily, right? So that that is why the reading is not same as per the statement, right? From the reading they are not same, right? So how we justify it? There could be some error in placing the pins because the thickness of the mirror itself is not accounted for. So as per this, we understand that the thickness was not accounted for. Instead, the reading should have been from this point, right, to this point, instead of going to this. So that must not be done. This was the right method. So that means the thickness was actually 0.3 centimeter, 31 centimeter for mirror, right? Over here we can actually find the thickness as well using this method. I hope I was able to help you understand how to get through with these ray tracing questions. They're a bit difficult in terms of accuracy, because you need to be very accurate while handling information, especially these steps that you need to follow in solving these questions. But regardless, they are worth quite the marks. So you need to put in the effort, you need to practice some of these questions to be able to answer accurately and to have the best scores possible. Thank you.